So for exploratory data analysis, the key objectives of the course here are: one is we'll learn the different plotting systems, then the principles that we use uh, for exploratory data analysis, and then a couple of case studies. Yeah. And then amongst the principles, the first one is that we have to show comparisons. Compared to what are we saying that this is the change, right? And then the causality is important. What's the cause of this? And the mechanism behind the causality and explanation of the causality. Yeah. So all of this put together is the second principle, wherein you show the causality, show the mechanism, and explain the whole thing. And then we say we should have multivariate data. We saw two examples. One was of seasonality, explaining the actual expected results in case of mortality as the pollution concentration increases, right? And secondly was education versus height versus age. So uh, therefore, we say multivariate data is very important. And then, fourthly, we say we got to integrate different modes of evidence, whether it is words, images, numbers, diagrams, everything. This whole thing becomes data graphics, and we have to have everything when we're doing our exploratory data analysis. Yeah, and then the tools should not end up driving the analysis; rather, it should be the other way around. Yeah. And then finally, the fifth and the most important point is you build your credibility with for whatever you're doing. One is that you say, okay, what you have to provide the source of data, whatever you're conveying, what is the source of data for that? And secondly, whatever code you used to come up with your exploratory data analysis should be also provided. And lastly, remember that finally everything is about the content. If there's a quality in your content, then there will be quality in whatever analysis you do, and the content has to be relevant. And when I say integrity, means the content should have a proper source which is reliable, and which is what we're pointing out to. Yeah. So all these things form the principles. And then we looked at the exploratory graphs. We said in the graphs there are a couple of things. One is you understand the different data properties. Yeah. And then you find out whether there are any patterns, and then you figure out some modeling strategies, and figure out what how can you analyze your data. And lastly, you communicate results. But we say communicate results is not part of the exploratory data analysis. The first four steps only constitute the exploratory data analysis. And then, so what are the characteristics of EDA or exploratory data analysis? One is you make the graphs very quickly in large numbers and mainly for personal understanding. Yeah. And later on, you will kind of clean up all the access legends and everything. And you mainly just use color and size to kind of differentiate between different data. Yeah. And so here we had looked at one example that was about pollution levels, annual pollution levels averaged over 3 years for the US. And then we wanted to see for how many counties or how many locations the data is exceeding the limit set by the US government, which is 12 units. All right. And then we said, okay, there are different ways to look at the summaries of data, simple summaries. There are 4 or 5 methods. One is the 5 number summary. Actually, it's a 6 number summary, straight away available using the summary function. And then we have a box plot. We understood how a box plot works. The key thing to remember here is that the lower bound is a calculated value, whereas the actual but the whisker actually is the lowest data point which is greater than the lower bound. Yeah. Similarly, the upper bound is a calculated value, but the h here is a data point which is less than the highest which is less than the upper bound. And the advantage here is that it'll kind of give us an idea about the outliers. Yeah. And then we have different functions which we'll look at into more details today. And uh, then another interesting thing, let's look at this. You can actually output the box plot into a variable. All right. So and let's look at some of the code here, which is a box plot code. uh, let's say I have this data, right? um, uh, is it visible? The Please open the file. I would want you to open the file week one coder, the one that I sent you last night. uh, have you guys opened the file? You guys are there? Am I audible? Hello? Okay, yeah. Um, um, have you guys opened the file? Yes, we've opened now. Great. All right. So what I'll do is I'll just quickly pick up the lines of code that is there. Uh, I'm creating a data which is uh, uh, so I So what this is doing is basically just creating random number variables with different means, right? Mean 4, 6, 10, 4, and so on, and different standard deviations, right? And 100 data points. Okay, so I'm creating as many as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 series, all right? And basically, so my data frame has 12 columns of data. Yeah, so let me just execute this line of code, and then I come back to my code here, and if I say summary data, let's see what I get. So I have 12 uh, columns here, and I get the summary for each of these data points. Yeah, and now what I do is uh, so I come back to my lines of code here, and I say, okay, plot, give me the box plot. So I'm just taking box plot of data. uh, so or rather, let me just do it here. I say box plot data. Okay, uh, give me a second. This window is appearing on the second screen. Let me just put it up for the screen. My voice is cracking. Mm, oh, okay. What should be, what can be done for this? What? You didn't hear me at all. Uh, can you just check if your net is fine? But can you just check that the net is working fine and everything? Is this a problem with the net on your end, or is this a problem on my end, or is it a software issue? Just give me a second. Because of the full screen problem, I'm not able to push the. Okay. Hmm. I think everything needs to be kept as it is. Okay. And let's pull up the graph. So this is what you get. All right. So I plotted the box plot for different values. We had some 12 different columns, right? And so I used these uh, different columns to plot it. Okay, so now this is what you see. Okay, now what I'm doing is I'm saying, let's, I say some variable is what I put the blocks plot values into. All right. Okay, so now this is a variable, so let's look at what this variable contains. Now just look at what the variable contains. Now the variable var, uh, audible, am I audible? Oops, wait, what should we do? uh, Whenever I'm changing the screen, the problem is happening, is it? uh, let's see, I mean, uh, is it because then suddenly it starts consuming more bandwidth on your end, and then that's how you get the problem? It's working perfectly fine over there. Mehul, are you not in the class? uh, uh, you are in class, is it? So it's the same location. Um, Let me close down. Though as such, there's nothing else. It's cutting when I am explaining. Okay. So if for some of you it is working perfectly fine, and Kartike, are you able to hear it? While for Salman the voice is gone. Okay. It was working pretty neat in the evening the other day. Um, it means some of your networks are spread in such a manner that it's causing problems, is it? I can't see any other reason. Um, can we put at least one of the machines on a speaker? Like yesterday, Sirish had done that, right? Some small speakers. So in case my voice cracks, at least you can hear from the outside. I'm just waiting for some response. Hmm. Shall I continue? Shall I go ahead? I know, yeah, it disturbs people who are listening on the earphones. I know that. Uh, yeah, Salman, tell me. Perfect. So I'll just hold on for a while. I'll give audio rights to Tena, or to somebody at least. What will happen is I can hear back my sound. That way, I will also get an idea whether you are able to hear or not. Whom should I give the speaker rights to? Microphone rights to? One of you guys. Okay, Tana. Tana has put the speakers, so now I guess you guys. But I would want to give microphone rights to one of you people. Whom can I give the microphone rights such that his speakers are a little away from the microphone? Or maybe somebody who's using a headphone with a microphone connected to it. I'll give the rights to Kaustubh. Okay, so I have give. That's noisy. Okay, Anmol. Okay, Lavita, Dipankar. So let me just give. I've unmuted Anmol. So, oh, this end is very. No, this is very noisy here. Let me just check out Lavita's. Okay, this seems fine. Lavita, I've unmuted you. You have a microphone? Hello? You guys, everything okay there? Uh, uh, she just spoke. No, I couldn't hear her. I couldn't hear her. I think her microphone is yet to be kind of unmuted. She needs to unmute her microphone, maybe. From my end, it is clean. Uh, okay, let me just see if Dipankar can. So I'm muting my. Where's Dipankar? I don't see Dipankar logged in. Dipankar is not logged in. Is Dipankar logged in or not? Come on, somebody. Tenna has the speakers, no? Let me just. Okay, Mehul. All right. So, Mehul, can you just speak back?
Yeah, hello.
Yeah. Okay, good enough. I hear feedback loop. Are you also getting the same problem? Oh, it's fine for you.
For me, it's on the earphones.
Okay, it's fine. It's on loop, no? Yeah. Uh, Somebody else's microphone is on. No. Okay. I think I'll just knock it off. Doesn't matter. I'll continue. You guys keep giving me. What we'll do is it's as simple as this. As I'm speaking, right? Uh, One by one, you guys just keep putting that. Okay, you're able to hear me. In case you're not able to hear me, please immediately let me know. Yeah. And if some, yeah, so that's how we will proceed. So I'm starting now. Yeah. So we saw that if we put a box plot data into a variable, there's a lot of information that gets stored here. Yeah. So it's storing all the different informations about the box plot. Let me make it more simple. Yeah. So what all, because this way you'll not be able to make it out. What I'm doing is I'm going to do the same thing again, but this time only for one particular, maybe stat 11. Okay, one particular column. Wait, what was the name of the data? Stat 11. Yeah, so now if I look at where, what do I get is I get these five data points. Remember the min, the max in uh, so there are 100 data points. Okay, and then I get the values which are to do with the quartile 1, quartile 2, and so on. Let me just show you this plot. Okay, I say box plot. Okay, so this is the box plot here. So we see that there are one, two, three, four, five outliers here. Okay, and then we have all the other five values. So if you look at these five values compared to what we get in the statistics here, see this fifth value 7.429, this is somewhere here, right? 7, but this is the largest value there, right? And then you have this value, that is the 4.06, that is this value, right? The quartile 3. You, Lavita here's feedback loop. um I guess now it's okay. I have everyone else muted out. I really don't know how, why you should get the feedback loop. Lavita? Okay, was that an old message that just came up now? Okay, right. So you get this value. Then the third value is 2.9. So this is basically quartile 3. Fourth is quartile 3. 2.9 is the middle, right? So basically quartile 2. And 1.7 is quartile 1. Yeah. And then minus 0.84 is the low bound. Okay, and so you have 100 points, and these are the outliers, dollar out, right? So immediately you can see what are the outliers. These values 7.98, all these values showing up here, 7.6 and 9.3. Yeah, all these three values here, and then minus 2.7 and minus 1.1 are here. Okay, so uh, so what I'm doing is I'm going to put this also in the code. So I'm making slight changes on the fly, so that you can also refer to it. So I'm adding a code of line of code here at line number 18. I say var is equal to uh, box plot data dollar stat 11. All right, and then you look at what var is. So it'll give you all this information. All right. Uh, so moving ahead. Uh, so so this output is quite informative, as we said, and we have uh, uh, we see what all we can do, and in fact a box plot is very very informative. I mean, one of the best graphs to plot, say, especially say for example, if I was to do a box plot for the whole of the data. Okay, now just one graph is enough for me to to look at this whole series. So basically, this is 100 data points that I'm seeing, right? And out of the 100 data points, immediately I see, okay, this is the middle point, this is where the quartiles are, and these are the outliers. So, and I can see it for each of these ranges. Otherwise, say if I was to just plot these 100 data points on a line, it doesn't really make much sense for me. Yeah, so kind of summary of each of the columns comes up here, and suddenly I have a much more useful visualization of the whole data. So if I look at this data, what I can see is that somewhere here, that is the third column, uh, the the variation in the data is very little, right? And whereas in the last column the variation is huge. Okay, so that's how the advantage of the box plot is. Coming back to our notes, so we've already gone through all this, bar plot, everything. Okay, we've looked at these. uh, have you seen all this? Did I cover this or not, or I have yet to cover it? Margins, etc. uh, Hello, can I get some response from you guys? I haven't covered, huh? Okay. uh, all right, so how do you s- okay, so now I'll come to this in more detail later when we start talking about the okay, when we start talking about the base plotting system more in detail. For now, just want to tell you this. Let's look at again something here. If I say par, right? Par stands for parameters, and I say bracket open, bracket close. Okay, you guys should also be doing it yourself. Do you see what is happening here? Huge amount of data shows up, and each of these are basically parameters, and they have some default values or the values that have been set up. Yeah, so I see that there is something called um, column, so it says black, right? Color, sorry, color is black, so by default the color is black. Cul is black. uh, okay, and then I see the font again, it's one again, it signifies some color. Yeah, then I see this value called LAS. LAS will tell you whether the value is vertical or horizontal. Zero is standard horizontal. Okay, and then I have MF call. M means matrix, F is of, then matrix of columns. All right. So then similarly MF row. So typically they will have just an inverse of a value. So if it is 2 1, this will be 1 2, something like that, right? And then what else is relevant is PCH is the point that is used to draw the graph. Point type. Okay, so different values are there. We'll go through each of these in detail, but this is just to show you that the par function actually gives you that parameter. And uh, say if I was to look at a particular, now here the key thing is this: if I want to set it up, either I can set the value or I can query the value. I can see what is the value. To set it up, I should say par bracket open, and then whatever input parameter I put that. For example, this, right? I say par mf row is equal to c1 comma 2. Let me show you this. All right, if I say par on, to query it, this is how I have to do it. I say par dollar, say if I want to query just one specific thing, say if I want to query mf row. All right, so I say par dollar mf row, it is 1 comma 1 right now. On the other hand, if I want to set it up, I want to change it up, I say par bracket open mf row is equal to c 2 comma 1. All right, now if I say par mf row, the value has changed. Is this clear? So this is how I either set the value or get the value. Okay, so so as I said, matrix of figures, F stands for figures, filled in row wise or column wise. What does mean? What does that mean? Say, let's say I have MF row value is 2 comma 2, which means when I do the first plot the first graph, it will show up uh, here. All right, the first row will finish up, then the second row, and so on. We will look at this as an example. Okay, moving ahead. So on the other hand, if I was to do the columns, then it's that the first column gets filled up first, and then the second column. Okay. So now then there are margin parameters. All right. So MAR stands for margin. And again, there are four values in it. That is bottom, the bottom margin from the base, this one, this value here, bottom, then the left, then the top, and then the right. And similarly, there's an outer margin. And again, it has four values, which again, bottom, left, top, and right. Okay. Uh, so if we look at the values that are there for bottom and So if I say margin, right, oops, they'll give me an error. So I get these values. So by default, these are the values that are set: 5.1, 4.1, 4.1, and 2.1. All right. Similarly, if I say outer margin, it's 0, 0, 0. Okay. We will look at why is there a need for an outer margin as we move ahead. Okay. So another thing that we will look at is, we see, okay, there's something called a subset. I'm just digressing from this because we'll be using it in the code there. Okay. So a subset is basically, I want to subset a data. Now, how can I subset the data? I can subset it by uh, rows and by columns, right? So the subset has two parts. Basically, when I'm talking x comma subset, so x is the data that you need to subset, and what do you want to which rows do you want to subset it by? Typically, the word subset is for the rows. Okay, so I say x comma subset, and then what columns I want to select. So I filter the columns, and then the drop is equal to false by default. What does that mean? We will look at that also again as an example. This is now just to give you the definition of what a subset does. Drop is equal to false actually means that suppose you had a matrix, right? And when you're subsetting it, what will end up happening is, say the output is just one column. The subset function will actually give you a list, but just you don't really need the list. You can actually say that, okay, this I can actually convert it into a vector. So drop is equal to false will not convert it, but drop is equal to true will convert it. And we'll look at why is it needed and stuff like that. So for simple ordinary vectors, what will be the result out here? It's basically nothing but some subsets, and such that all the missing values are not taken. So the advantage of the subset function is that the missing values will already automatically will be knocked out. Okay. Uh, and another one is the AB line. Okay, and after I finish this, then we will move into the code part, right? So what does AB line do? Remember your um, say we say, give me a second, we say y is equal to ax plus b, right? So that is what an AB line is. So you basically draw a line wherein you specify the values of a and b. Okay, or the other way is you can specify the values of height and or horizontal value or vertical value. Okay, so there are multiple ways to draw the AB line. Again, we will look at each of these as an example as well. Okay, so uh, let me just quickly uh, tell you the three different systems that are there. We have the base system, and then the second one is called the lattice, and then the ggplot. So there are these three plotting systems that are there in R, which are extensively used. So the base plotting system is the one which came uh, okay, let me just tell you, I'm just going quickly through the theory initially, so that the ground is built up, and then we will move into the actual code. All right, so bear with me if you're thinking, oh, can I get an example out of this? We are going to look at each of these as examples also. All right, so the base plotting system is the base, it came with the, it's an older system which came with base R. All right, and what is it? Basically, it's a series of R commands. Whatever commands we saw right now, whatever I was doing, the box plot and everything, that is all base plotting system. All right, and so what we can do is, using, I can build upon the base plotting system. I write one line of code and I plot the graph. Then I can, with each new line of code, I can add to that graph as well. All right, and it starts with a blank canvas. So you start with a clean slate and then you keep on building up your graph. All right, and it's very very intuitive and convenient. But what you can't do is, you can't do an undo, for example, right? You have to rechange. You have to change your code actually. All right, so and therefore, so there is, it's not really a graphical language wherein I can just say, okay, knock off this part and stuff like that. I have to actually change my code. So therefore it cannot really be translated. So if I've drawn one graph, I can't give it away to somebody else just like that. I have to actually give the code. Okay, so that is a limitation that is there. Now on the other hand, the lattice plotting system, what it does is, it is a single function upfront. In the base plotting system, we saw that we are building up things step by step, but in the lattice plotting system, um, we are uh, using a single command, and this single command will have all the different parameters that you want to set up. All right, so and the functions are namely called xy plot and bw plot, etc. whereas in the base plotting system they are simply like box plot and stuff like that. Yeah, so this is BW plot is nothing but box and whiskers plot, which is similar, which is the lattice function, whereas the base function for the corresponding BW plot is called the box plot. That's what we saw so far. Okay, and now where is this useful? It is mainly useful where I want to draw multiple panels. For example, in the example that we saw yesterday, we said okay, change of mortality rate uh, with respect to the pollution, and how does it change over the 4 different seasons. So 4 different seasons are 4 different panels, right? So each graph is considered as a panel when we are looking at multiple graphs, right? So how do I draw those multiple graphs? I'm saying I have a condition. The condition is that for each season you subset the data and then plot the graph, and then take the next season, plot the graph, and so on, right? So it is most useful for the conditioning kind of a structure. We will look at this mathematically as we move ahead. Now, what are the advantages? It's very quick, and the biggest advantage is you can put many plots on the screen in one go. Okay, and what is the negative here? That it is quite awkward to kind of specify the whole plot in a single function call, right? And then the next thing is you cannot add to the plot once it is created. You can't generally. So this is called annotation. What, by the way, when I'm adding, right, say for example I add one line, I change the color, I add something else, all this is called annotation. Annotation is not very intuitive in lattice plotting system, though it is possible, but it's not the main feature of lattice plotting system, whereas the base plotting system gives you that. Okay, so now this is the mathematical functionality here. Say if I say xy plot, right, I want to plot the values on the y-axis versus x-axis. I say y tilde x. All right, so this will be the y-axis, this will be the x-axis. All right, and then what are these? G1 plus G2 plus G3. These are all the conditioning variables that I normally have. Typically I will just have G1 or just one condition, that will be good enough. Okay, and now know one very important thing, that what are these conditioning variables? For example, I said seasons, right? So now there will be 4 seasons, and based on those 4 seasons, that is the number of panels that will get created. All right, so this G1 plus G2 plus G3 actually creates the number of panels, which could be 4, which could be 6, which could be 18, whatever, right? But it cannot be a very large number, otherwise you can't really see anything, right? So typically you will have maximum maybe 4 panels, or maybe at max maybe 16 panels, right? So if that is the case, then this data should have a very limited number of variables, right? You understand this point? Because it is kind of going to divide this data based on these variables. Okay, it's going to subset the data which is y and x based on G1, G2, and G3. So now, so therefore what I'm doing here is that these are values which are actually going to be either factors or shingles. I will look at what a shingle is. All right, I will explain what a shingle is, but factors you understand, right? For example, if I say male female, so there are two factors there, right? So the data is factorial, factor form, and the factors are male and female, right? So the unique values of the data are the factors. And so shingles is one thing that I'll cover. And another thing is that the x and y, they should be numeric, whereas the conditional variables, they just should need to be factors or shingles. So in case these are not numeric and they are a factor, then the level is used for the factor and not the values. So if I say male and female and I want to plot it for y and x, right, then male will not be treated as male, it will be treated as either number 1 or number 2, and similarly female will be treated as 1 or 2 based on how the levels are. So is this part clear? So primary variables will have to be numeric in nature. In case they are factors, then the level of the factor will be used as the axis labels. Okay, so another thing is that I can also use y1 plus y2 tilde x. So here what will happen is basically superimposition of the two values will happen. Again, we will look at each of these as an example with the code, so that you can also work it out and actually understand this practically. Yeah, so this is just the mathematical explanation of lattice plots. Okay, and then lastly we have the third functionality that we will have is called the ggplot2. Okay, 2 means the second version came up. So GG stands for grammar of graphics, and it is basically based on a very strong theoretical framework, wherein it is taking the best of both the lattice as well as the base plotting system. So both things you can do. One is it creates the plots automatically just like lattice does. At the same time, you can keep on adding to the plot. Okay, and it is much more intuitive than the lattice system, and we already saw that the base plot system is anyways intuitive. So this was the feature that was lost in the lattice system that gets added back in the ggplot. Okay, and the default mode itself makes many choices, but you can do full customizations here. Now, syntax of one of the ggplots is a q plot, where I say x is x-axis, y is y-axis, and then I have the data. All right. So now we'll begin with the base plotting system. We'll just look at the functionality. Once we are done with this, we will start getting into the code part. Okay. So we say, okay, now the base plotting system will have uh, so it has the core graphics and the plotting system are there. Basically, there are two packages which, say for example, when I say box plot, right, you see a quartz window opening up, right? So what's that window that is opening up? In those people who are using a Windows machine, you have a different kind of a window that's opening up. They're called the GR devices. So all the packages have all the, so the device part is taken care by the GR devices package in R, and then the graphics functions that are there, for example plot, hist, box plot, they are in the graphics package. These two together form the base plotting system. Now, how is the lattice plotting system different? The lattice plotting system has two packages. One is the grid and the other is lattice. Now, the grid is kind of a wrapper around the GR devices package, all right? And then the lattice is a replacement for the graphics package of the base plotting system. So this lattice has all the functions like XY plot, BW plot, and everything. Okay, so this is just a little understanding of the plotting systems and what they constitute of. Okay, and so now when you're going to do the plotting, there are a couple of questions that we need to ask. So first is, where do you want to plot? Do you want to plot it on a screen? So far we have just seen that we're plotting on a screen, right? Second is, do you want to plot it on a file? Right, so different kind of files like say PDF or any other file, right? So first question that you will ask is, where do you want to plot your graph? Second question is, how do you want to plot it, right? Do you want to directly just uh, uh, how do you want to use it, rather, not the how do you want to plot it? So is it just for the exploratory data analysis purpose, which means it'll be just typically on a screen or a PDF or anything like that, but you will not bother too much about the presentation, right? Or is it for printing purposes? You actually want to print out the graph. Or thirdly, it is actually for a presentation purpose. Now, um, um, typically what happens is, when you're printing something, right? So when you print something, then the graph is very close to somebody, right? So they see it in a book or something, so the lines can be very fine and you can still read the small print. But if you're doing something for a presentation purpose, right, know that there's somebody sitting at the back of the class, so they should be able to still see stuff that you're printing, or they should still be able to see your graph. And therefore, printing would have a different kind of graph, whereas presentation will have a different kind of a graph. And then the third question that you want to ask is, what's the amount of data that you want to print? Do you want to print large amount of data or small amount of data? Okay, and do you want to resize your plot dynamically? What does that mean? For example, remember in Excel I showed you something when I say you can actually convey different things from a graph based on how you've sized it. So I make the x-axis really small, it will convey something else. If I make the y-axis really small or large, it will convey something else. So do I really need to do dynamic resizing or not? For example, if I was to plot a photograph, I don't want to do dynamic resizing without keeping x and y locked, right? Otherwise it will deform the shape. But if it is a line graph kind of a thing, I can do dynamic resizing. I just want to see how it looks the best, right? So this is another question that I want to ask. And then lastly, the question that I would want to ask is, which plotting system I want to use? Do I want to use the base plotting system, lattice plotting system, or the GG plotting? All right. So now coming to base plotting system, now there are two parts to it. Step one is what you initialize. So for example, what are we doing? For example, let's look at this. I said box plot data, right? So I get this. Now, I add, um, I say pair call is equal to red. Let's see what happens. Now this doesn't change. Then again I say box plot. Now do you see, this time when I print, I get a red box here because I changed the parameter. So I kind of keep on annotating also. So this is not really an annotation, this is just a changing of the parameter, global parameter. But I could do the same thing inside here. I could have said data, then color is equal to red. Alright, so I get the graph like this. Is this clear? So this part is called the annotation, wherein I can keep on adding stuff. I can keep on adding stuff doing separate lines also. For example, I can say AB line. I can say AB line at a horizontal value of, or rather I say vertical, AB line at a vertical value of 0. All right. So what happens is, they should be, sorry, h is equal to 0, which right, at h is equal to 0 I'll get a line here, right? So this is what is annotation. So I'm keeping on building my plot however I want to build it up. Okay. So so I initialize the plot and then I annotate it. Okay. So I use these functions, a handful of functions to initialize, and then how do I annotate? I use the pair function, right? So it will affect all the plots that are plotted after I have changed any parameter. Okay. So after I change the parameter, whatever is plotted, all the functions will capture that value. But at the same time, I can overwrite also by specifying the value within the function. So is this part clear? What does that mean? For example, I had said let us do this. I say parameter color is equal to blue. Okay. And then I say box plot data. Now what happens is, now this is doing the color blue only for the boundary here. Okay. On the other hand, if I say parameter color, uh, box plot data color is equal to red. Okay. Now in this scenario, what has happened is this blue stays for the outer value and this color is gone inside here. Okay. So I'm kind of, I can override those values by specifying the arguments within the functions as well. When you start practicing it, you will learn this, right? Otherwise it may sound a little confusing. Okay. So now let us look at some of the key parameters that we need to remember, kind of, right? One is the plotting symbol. So PCH. Now this can be either a number or a string. Okay. So let me do a scatter plot. So I would say, let me just simply say plot. I say plot data dollar stat 1 1. Okay. So now what I get is this, right? This is how my values are distributed. Now if I say plot data, then I say PCH is equal to 2. Do you see this? So I get a triangle here. By the way, why do you see this? Can you tell me, every time I'm plotting, like this time again, if I run this command, let's say I say 3. Okay. I'm getting a graph here, then I got a graph here. Now this time when I run a plot, what will happen? Let's say I do a 4. I'm getting it here. Why is this happening? Why am I not getting one graph in one sheet? What's the reason? Why am I getting two graphs in one sheet? Hello class, you there? Right. Yeah. So I had set, if you remember long back, I had set par is equal to 2 comma 1, right? Par mf row is equal to 2 comma 1. That's why, exactly, right? And that's the reason why this is happening all the time. Let me just kind of rechange it. So it's, I say par mf row is equal to c 1 comma 1. All right. So now when I do a plot, so I get it in one shot. Yeah. So, or rather, in fact, because we want to see multiple things here, right? Let us do 2 comma 2. So we'll see different plots. We don't need to keep on changing. We can compare them easily. Yeah. So PCH is clear to you? Yeah. So PCH is the plotting symbol. Then line type. What is the kind of line that I want to use? Line width. Whenever I'm using a line. So again, we will see, you can just actually try these out. We will. I have not even yet touched my week one code file. This is just going through the notes, and that's how I'm explaining. But we will go through the week one code file, and there we have enough examples for each of these. Okay. So then we have the line width, color, then label and y label. What is the label that you want to use on the x-axis and the y-axis? And now these two are not a part of the pair function. All of these are part of the pair function, but still you need to remember this. You can use them directly as arguments in the functions. So in the plot function or the hist function, you can directly use them. All right. Other than that, there is margin size, then outer margin. Now, why do you need the outer margin? Because say for example in this case we have four graphs. Let's look at this, right? So we have set this up, and I say plot PCH1, plot PCH, another one, with color is equal to red, okay, and then the fourth one with color is equal to blue, okay. So I have these four now here, okay. So now hopefully I have the outer margin. Now I can say um, mm, wait, we'll look at those examples later. So basically, if I want to give a title to all of these four together here, that title will come in the outer margin. It will not be in any of these plots, and that is why I need the outer margin. If I don't have the outer margin, I cannot have a common title for all of these four plots. Okay, and then background color BG. Last is the orientation. So basically, either I can have the vertical or the horizontal orientation. In this it's just numbers, so you can't see much of difference. But we'll see this in a different example, okay. And all right, so this is a little bit about the pair function. So plot initializes the plot, and all of these lines, points, text, title, mtext, axis, they add to the plot, so they are the annotations, okay. So let me just quickly go through the graphic devices and then we move on to the code part. Yeah. So what are the different graphic devices? So what is basically a graphic device? Where your plot appears. You have written some code and the plot appears somewhere, right? So either it can be a screen device or it can be a file device, right? So most common on the screen devices. So again, screen devices, there are three. Quartz is for Macs. So on a Mac, you have a Quartz screen device. On a Windows, you have a Windows screen device, and on a Unix machine, you have an X11 screen device. All right. So there'll be only one screen device per platform. You can't have multiple of these. At the same time, only one particular quartz screen will be active. So you can have multiple quartz screens open on a Mac, let's say, but at any given point in time, there will be only one screen that will be active. All right. So let us just quickly look at this. So these are the different devices that are there, right? So you have the PDF. So these are not the screen devices; they are file devices. So PDF, PostScript, bitmap, all right, X11. So different kind of devices are available to us. Okay, and so now the screen devices, what you do, you basically call the plot function and the function appears on the screen. This is what we saw, right? Now in the file device, what you will need to do, so these two steps are anyways, but there is one more step initially, that is you launch that particular graphic device, okay? How do you launch it? We will look at that. And then you call the plot function. Now the plot function will not appear on the screen, but will go into that graphics device. And then, so that's what happens. And then you close that particular graphic device using the function called dev.off. Okay. So what are the commands used to open the graphics device? Different commands for different file types. So for example, if I want to open a PDF, then I say PDF bracket open plot1.pdf1, whatever the name of the file, right? And then the PDF device gets opened. And similarly, the PNG, I just need to say PNG and the file gets opened there. Okay, right. So now coming to file devices, again the file devices are two different formats. One is vector format and another is bitmap format. As we say, vector means what, typically one column, right? So they're most useful for line type of graphics, all right. And a PDF is used for this kind of format. PDF is one very commonly used vector format. Okay, it will be very easy to resize these files, but if they'll definitely not be efficient if you have too many data points. Let's say you want to plot a picture, right? Now plotting a picture means too many data points, too many pixels, right? So you will not use PDF, you will not use vector format. All the examples, Salman, everything we will look at as an example. I'm just kind of quickly covering through the theory part, and then we come back to the code and we will look at everything as an example. Yeah. So in fact, all the examples are pending. Okay. So basically what happens is when you have a little bit theory in the mind, no, so when we look at the examples, things will become more clear then. Yeah, so that was my idea of kind of quickly going through the theory first and then come to the example. Is that okay? All right. So you have the PDF, and then you have, say, SVG files, which are again very scalable and used mainly for web-based plots, supports animation and interactivity. And then win.meta file again is another format which is just there for compatibility, and then the PostScript. All right. So these are your vector formats, and then you have the bitmap formats, which are mainly for the images. Okay. So basically all this theory is mainly helpful for you in the quiz. Okay. And then for the project, we are going to focus on the code, and that is where it'll come to. So I'm just kind of covering all the theory so that when you see a quiz, you'll be very quickly able to finish it off, right? So so bitmaps, normally you would not want to resize them. I mean, just imagine, you don't want to distort an image, right? If at all you want to resize, you will just kind of change the ratio. The XY ratio should stay the constant, right? So it's basically series of pixels, bitmaps, right? So they're very good for the large number of points. For example, PNG is there, JPEG is there, TIFF is there, and BMP. So these four are there, right? So PNG, again, good for line drawings and solid drawings also. Uh, it has lossless compression, so I'm just differentiating all of them. And the most browsers can reach PNG files. The file size is typically small, okay, but they do not resize very well. JPEG is a very good for pictures, lossy compression, so if you compress it, you lose some data, and can be read by any computer in web browser, we know this. So, again, very efficient file sizes. Again, they do not resize very well and not good for line drawing. Third is TIFF, lossless compression, but this is an old format. And BMP is used for icons mainly. All right, so all the icons typically BMPs are used. Okay, so now multiple quartz windows can be opened. Now what's happening is we are having just one window, right? Every time I'm plotting, it is going on the same device, right? We think, oh, this is the only way. Actually, you can open multiple quartz windows. How do you open it? You run the function quartz. All right. So when we run the quartz function, it opens the multiple windows, right? And then dev.cur will give you the current active window, and dev.set I sets the active window. Let's look at this. So if I say dev.cur, I get two, right? So quartz window number two. Let's see if there is one also open. There isn't. Okay, so quartz 2 is open. Now if I say quartz, all right, so let me just run the command quartz. So now what has happened is another window is opened up. Let me pull it up for you. So it's a blank window. Yeah. So I have this quartz 2, if you notice here, and then I have quartz 3, right? If I run the quartz command one more time, another blank window has opened up. So I have three of them. Now, which is the current one? If I say dev.cur, the fourth one is the current one. So if I plot something now, let's say plot this. Now it has gone into this quartz 4 here. Dev.cur only gives you which is the current window, the number of the current window. So I have 2, 3, and 4 now. If you notice here, so I have 2, 3, and 4. So dev.cur will give me the current window. Every time I'm opening a quartz window using the quartz, that becomes the current window. Just like Excel, right? In Excel, if I add a new sheet, that sheet will be the active sheet at that point in time. Yes, Salman. Yeah, what does it give you? R Studio GD. I don't know. Is it you? Is it something? Guys, please check this. Everyone do this. I thought maybe. Oh, okay, okay, okay. Quartz is actually, we saw it's only a Mac. This thing, right? Windows will have something else equivalent of this. Can somebody quickly? Yeah, yeah. So Windows will have, right. So Windows will have a corresponding equivalent. Yeah, window maybe. Yeah. So that's it. Sarvani said window bracket open bracket close. Just check that. Uh, yeah. Hmm. It's not giving you any numbers, is it? Okay. And what about the rest of you people who are using Windows machines? What do you get when you do dev.cur? Okay, but you were there in the class, Debashri, all this while? Okay. Uh, okay, Debashri. Um, so guys, what is it if you do dev.cur in Windows machines, what are you getting? Salman is getting RStudio GD, he said. What about the rest of you? So dev.cur, yeah, what is the dev.cur giving you the output as? All the Windows people, all the Mac people also. Please try this out. Please type your output when you do dev.cur. Oh, okay. Uh, I have started using R. I don't use RStudio. Somehow I prefer R. Uh, I think it's at least I found it better than RStudio in some ways. Uh, I mean, I'm sure people are using RStudio and that might be good, but I somehow found that the base function, the base UI that is there is much more neater. In a sense, I have more control over it. So I think that's the reason. Uh, how about you guys using R instead of RStudio? Probably that explains it. RStudio at GD you're getting is because you're using the, so basically the graphic device is different, right? So GD stands for graphic device. RStudio GD means it's an RStudio's graphic device and not the uh, R graphic device, the standard R base plot graphic device. Yeah, does that explain it? Mm, no. All the colors etc. are also there. You just need to change the settings. In the code, you mean to say, right? In the programming code, yeah, the colors won't be there. But you get used to it, I think. Uh, so have you guys opened R instead of RStudio? Can I move ahead? Why dev.cur is used? In Excel, we say active sheet, right? Or active cell, which is my active cell. When I type something, it goes into the active cell, right? In Excel. Similarly, here, if I have four different quads windows open, right? Four different graphics windows available to me. On which one will the graph go? It will go on the one that I have specified. This is my current window. So how do I know? I say dev.cur. At the same time, I can set it up. I can say dev.set I. Let me just show you this. Um, you can see that I have three quads windows, quads 2, quads 3, and quads 4. Yeah. Now, if I say mm, dev.cur, dev.current, all right, cur stands for current. Okay, I get 4. So now I say plot. So I'm plotting this graph. Let me make the color red. Okay. So before I execute this line of code, I'll just show you that there are these different ones that are lying here. Okay. So let's see where the graph goes on to. So I have the quads window 2, the 3, and the 4. Okay. Uh, so I come back to my code here and execute it. Do you notice which one it has gone to? It has come to this. This is quads window 4. So that was the active one. On the other hand, if I say dev.set to, let's say I say dev.set is equal to 3. Okay, now let us see which is, this is 2, this is 3, this is blank. Okay, so I'm again going to execute the same command, this time with a different color. I say green. Okay, so where has it gone? It has gone into the quartz window 3. You saw this, all of you? You saw this and you understood this also? What does the, and how does the current window help us, or rather what is the functionality of the current window? The rest of you also understood this well? Can you please just respond? Let me just get some responses back, so that way I know that you guys are active also. So I see 20 people here. Okay, okay, great. All right. So let me move ahead. Hmm. So this is how I basically open up multiple windows for graphics. Okay. So now what do I do? When I want to copy it into a file, I can use a command called dev.copy. Okay. So it will copy it into the screen to the file, or I can say dev.copy to PDF. Hmm. So let me just, so copy to PDF is specifically for a PDF file. So copying a plot is not an exact operation. Remember this, very very important. So the result may not be identical to the origin. What that means? So when I'm copying it, the graph, the way it appears on the screen, need not exactly appear the same in the file. You may see that, okay, somewhere the size has been, cramped up, or font has changed or something like that. So so this is this is very important to know. So in case you're looking for the exact graph as it is, then there's a different method. Yeah, dev.curve will work in R, Salman. Yeah, yeah. So it gives windows, or rather, does it give you a number? It doesn't give you a number, one, two, three, or like that. The output. So Salman says that yeah. Okay, both. Great. So it works as on Windows as well, the dev.curve, as long as you're using R directly. Yeah. In fact, this was the time when I actually stopped using RStudio and started using R. The first time I did a plot, I figured that RStudio was creating some problems. I was not very happy with it, and that's when I moved to R. I found that it was much more neater, and it was behaving the way it was expected to behave. Okay. All right. So. Uh, okay, so let's so remember this very important aspect. Okay, when we look at when we actually start, this will be helpful in your project. Okay, the point that I'm making here, that originally they are, because in the project they're saying that you have to draw the exact. Okay, so we're done with the notes. Okay, let us actually move on to our code now. Okay, uh, so we've already gone through this, uh, all this. Okay, so 2D plots, right? This is what we want to do today, right? Okay. uh, Shall I open the slides for you? How do we want to do it? Will that be better, so you can see the slide also and the actual one? So I'm closing this for now, and let me open the PDFs, corresponding PDFs. Mm, I've gone through all this. Okay, so two-dimensional plots. Okay, so let's start going through this as a code. So let's come to our uh, so line number 124. 2D data plot, right? From there, this is what we will start looking at from. Okay, so now what I'm doing is I'm saying give me a box plot separated by region where the data is pollution. Remember the let me just uh, revisit the data for you so that you are at least familiar. I say pollution. Okay, rather let me just say summary pollution. All right, so I have these five columns in the data pollution: particular matter, and then the ID. So now this is ID which has length. 576. The class is character, mode is character. Then region is east or west. Okay, and this is a factor. All right, and then the longitude and the latitude values. All right. So now what I want to do is say I want to do my box plot split across regions. Okay, so two different regions. So the command for that goes something like this, as it is in the line. So I say pm particular method tilde region. So what it will do is it will subset the particular method for that particular region. So I have two regions, right? So I have east and west. So only the east data will be pulled out from the data, that is pollution, and that will be printed and so on, right? So if I run this command, line number 125. By the way, you can just select the line. You don't need to type it or copy paste it. You just select the line and then just do control and enter, and that line will get executed. So what I see, and I have set color is equal to red. So I get the red color, and I see east, the data is like this, and the west, the data is like this. And on the other hand, say I want to execute the next line, that is line on. Are you also executing it? Line on the code of line on line number 126. So here I said, give me red and blue. Okay. So wait, what has happened? Oh, this is, where's my window? Let me just close some of them. Okay. So now I get this. Is this clear? So when I change the color column, so now red will be going for the first plot that is there, and blue goes for the second one. Okay. So now let us look at the pair function. We have already seen the pair function. We have seen these values also. Now I can set up values, right? Let us say I said initially I said pair is equal to mf row. Uh, wait. I just want to make sure that the screen is a little better visible. Right. So now what I'll do is I'm setting the margins as 4 comma 4 comma 4. Okay. So I do this and I hit enter, but that's, and then I plot. All right. So I'm plotting the pollution latitude. So I'm doing an XY scatter plot. Okay. So basically it's just a straightaway plot. So this is what I get. So my margin is 4444. Okay. Now I'm changing the margin. So this is just to understand the margin function. Okay. So I'm using the line number 136. Are you guys also executing it along with me? Just select one line and execute it. So now if you notice, it has kind of collapsed. There is nothing that is visible here, nothing here, and so on. Yeah. Now what I do is I say line number 137. So I set the margin to be 0. Let's see what happens. So I don't see anything else other than the graph. Okay. Now what I do is I say set the outer margin. So I set the outer margin to 2222. Okay. And then again I draw the graph with the margins as 0. What happens is I get something at least because of the outer margin. All right. Now it is the same as I say the outer margin is, now look at this graph. Okay. In quartz window 3. Okay. What I want you to do is just notice that the same graph will show up uh, if I initially, what I've done is outer margin is 2222 and the inner margin is 0000. This is what I get. Okay. If I was to change it, okay, such that uh, sorry, this is the, okay, this is how it looks. So if I was to change it such that the outer margin is 0000 but the inner margin is 2222, I will still get the similar graph. Is this part clear? So outer margin and inner margin, when I'm just drawing one graph, will not make much of difference. Only when you have multiple panels, it will make difference. So what I'll do is let me just uh, plot it on a different uh, quartz window. So let me plot it on the second one. Okay, so what I'll do is I'm changing this line of code. Let me just say dev dot set 2. All right, so and then I'm plotting, and let me change the color also. So I say color is equal to red. Okay, so this is line number 139. Okay, I've just modified it a little bit. Okay, and then I execute it. All right, so let's see what happens. Where is our quartz window 2? Here it is. Okay, so now in the quartz 2, I guess we had the setting was such that it is the panel has MF rows 4 by 4. All right, that's why it's showing up like this. What I do is let me just change that also. I can let me copy this here. Let me paste it here and re-execute this line of code. Okay, so now this is what I got. No, but before that I have to do this also, right? I have to set the outer parameter to 0, 0, 0. So if I do this, wait, some now if you look at these two graphs, quads 2 and quads 3, you can see them. They are, other than the color, the way they have drawn up as far as the margins are concerned is same. In the quartz 2, that the red one, what I did is I set the outer margin as 2 2 2 2, whereas the inner margin is 0. Here I have the outer margin as 0 0 0 0 and the inner margin as 2 2 2, right? And at the same time still I get the same result. All right, so is this clear? Outer margin and inner margin are clear to you guys now? So I have one more example for the same thing. Anyways, moving ahead. So now let us come to the line number 143. Remember we talked about subset. So I say subset. What I want to do is so now I have plotted this graph, right? But I was able to plot it using box plot. What if I want to plot it using, say, scatter plot or some other way? So yeah, Lavita, what is not clear? The OMA and the MAR part is not clear, right? That's what you're saying? Wait, how about you just executing these lines of code? 138 and 139 versus 140 and 141. You will see that both of them give you the same plot. The file that you have, in that file, first you plot your graph using line numbers 138 and 139, and then you plot it using line numbers 140 and 141. Is my uh, uh, question clear to all of you guys? If whatever I just explained right now is not clear, all you need to do is plot the graph using 138 line number and 139 and then replot it using 140 and 141. Have you been able to do it? Class, have you been able to do it? If yes, please respond back to me. How many of you have done this? You've executed line numbers 138, 139, 140, 141. Mm, uh, okay. So Lavita's keyboard is not working, is it? Okay. What about the rest of you? You guys have been able to follow it? Can I move ahead? Mm, let me just redo this. Okay. Um, so this is my plot. Okay. I'm just plotting something else for now. Okay. Just so that this gets cleared off. Let me just do maybe this. Okay. So this is my, so I've plotted something here. Okay. This is what was the original plot. Now what I do is I come to my lines of code and let me change it back to, uh, I'm not using this. Okay. Just so that the code is same as what you have. Okay. There's no difference in the code. I had modified it so that I can explain something more, but I guess that's all right. So I'm executing these two lines of code, 138 and 139. So I get this. Is this clear? Now what am I doing here? I said outer margin 2222, and this is what I get. And then inner margin is set to 0000. Now I'm going to reverse the same thing. Let me, before that, so remember this graph. Okay. I replot some other graph. Okay. Just so that this one is gone. So I've replotted some other graph. Okay. Now I come back to line number 140 and 141 and I execute that. Now do you notice that it is the same graph that is getting plotted, which was getting plotted when I was executing line number 138 and 139. So basically what is happening is the outer margin or the inner margin, they both of them add up. So I say 2, 2. If I was to say, let me do one more small thing. I think this should make it very clear to you guys. Um, so I'm adding two lines of code here. Remind me to delete it so that our line numbers remain the same. Okay. So I'm saying I'm setting the outer margin as 1, 1, 1, 2. All right. And then the inner margin I'm setting as 0, 1, 1, or rather I'm setting this. All right. So the sum of both of these outer margin and inner margin is what? 2, 2, 2, 2. 2 plus 0, 1 plus 1, 1 plus 1, 2 plus 0. Therefore, the output that I would get in this scenario would also be the same as the output that I got in the previous two cases. Let us look at that. Okay. Again, for the sake of showing you that I'm getting the same plot, I'm deleting this and I'm replotting it using line numbers that I've drawn here. I get the same plot that I was getting when I was executing the lines above that. So, so let us, so that my line numbers don't change, what I'm doing is okay. So I have, is this clear? Has it become clear now? What is it? Outer margin, inner margin? You have to just, basically I'm just trying to, giving you multiple examples of outer margin, inner margin, so it becomes more clear for you. At the same time, I took a boundary case to explain it actually. So class, is it clear? Can I move ahead? Okay, right. So now let's move to the subset function that we learned. I want to subset my data on pollution. All right. So I'm just subsetting it. Okay. So I'm doing nothing else. So I'm saying subset. So when I do this, what is happening here is the data that I get here is only that data. So this data is such that region is east. Okay. And then I'm selecting only the particular meta 25. So only some of the data points are there. So how many data points are there? 567. All right. So let me just do this. This was my line of code. I say n row 442. Okay. And what is the total number of data points? I can say n row pollution Okay, so I have 576 total rows. Out of that, 442 are there in the east. Now let us do the same thing for the west. Okay, so if I was to see how many rows are there for west, let me just change this to west. So I have the remaining ones into west. So 134, if I say 134 plus 442, that's 576. Is this clear? So I'm splitting my data, I'm subsetting it. Okay, so this is the function for subset. And then I say drop is equal to false and drop is equal to true. Let us look at the difference. When I uh, the number of rows might not change because there is no data which is missing. No, wait. What I'll do is, so I have, if you look at the line number 145, okay, I'm wanting to find out the mode of that function. In one case I say drop is equal to false, okay, and the other one I said drop is equal to true. So if I say mode of this, I get list with the line number 145. Now with the line number 146, I say drop is equal to true is the change that I have made. I get numeric. So is this clear? Why I would want to use drop is equal to false or true? Whether I want to use output as list or a vector. So that is where the advantage of the drop function, drop argument in the subset function is. Okay, so basically the drop is equal to true has converted that subset into a vector. It was a data frame, right? It is a data frame. Remember, the data frame is like a list. Okay, so when I was pulling out just one column out of it, it was coming out as a list. But I say now that only one column is left, convert it into a vector. So what drop is equal to true does is it converts it into a vector. So now I can, so this is the command that is there, hist function. Say I want to plot the hist function, okay, and I want to plot it for this subset, okay, so this subset of data. So I'm using the subset function. So what is happening is I'm executing line number 149. Are you also executing these lines? All you need to do is nothing. You just need to keep your cursor on that line, okay, and press Control Enter. I get an error here for line number 149. I get an error. The error says X must be numeric. Now what is the problem? Can somebody tell me why am I getting this error when I'm using the hist function on the subset? Hist function should look for a vector. So why is the error coming? What is the cause of the error? For hist function, the input has to be a vector. Now when I gave this input as subset, uh, why is the error coming? Hello, uh, any of you guys? What is the reason for the error? Execute line number 149. Please tell me why the error is coming. You guys can hear me? Hello, am I audible? Okay, so expecting an answer from each of you. Uh, why does the line number 149 give me the error? You can execute the line and okay. No, that's it. Basically, I was just looking at this answer. Basically the hist function. If I do a help on hist, exactly. So it's taking a list, right? So subset is actually giving back a list. All right. If I was to just straight away say pollution dollar PM25, it would have worked fine. But this is giving me a list, and that's why I'm getting the error. Okay. So how do I get rid of? Yeah, it's not a vector. So how do I get rid of that error? I I execute the line number 151. Check the difference between line number 149 and 151. Right. So when I do drop is equal to true, wait, sorry, let me just readjust things. Is your line number 149 empty? Are you using the file that I sent the last night, Salman? I sent a file last night. In your case, are our files matching or not? Please, Salman, please use the latest file. No? I made some changes in the code and therefore the line numbers may not match. The previous class one, no? please use the latest one. Okay, so if you notice, the drop is equal to true takes care of this problem. So I execute line number 151 and I get the graph here. All right, so I'm getting the graph wherein it is plotting only for the region east. Okay, so now I can get rid of the same problem. See, I don't now look at line number 152. I do not even bother to mention drop is equal to true. By default, drop is equal to false. Okay, all I need to do now is if I so I subset my data by region is equal to east, but I don't select any particular column, and then I say $PM25. This will give me back a vector, and automatically the hist function will work fine. Is this fine? So this is what I get the output as. Are the two outputs same? Yeah. Is it fine? So have you executed line numbers 151 and 152? Let me also open the slides for you. Hmm. Wait. Okay. So I think this should be good enough. You can see the whole screen, my screen and everything also. Oops. Wait, let me just reduce the size here. So basically what I'm doing is, so I executed this box plot, right? Now I'm saying I want to do it using the histograms. So how do I do it? So first thing is this. I will say make my mf row is equal to 2 comma 1, and then margins whatever I want to set it, and then I use the subset function here. All right. So this is my slide number 18. So let me just uh, so slide number 18 is explained at point number 154, right? Line number 154. So I'm just executing those two pieces of code and I will get exactly the same graph. Only thing is I've chosen a different color. So is this clear? Any question here? What I do is in one case I subset it by east, the other case I subset it by west, and then I plot it using the histograms. And then I use the MF row so that I can plot two of them and then the margin set to 4. So are the line numbers 155 to 157 also clear? Have you executed them? Now MF row is also clear to you, right? Can you use multiple conditions? For example, let's look at that. Uh, Sorry, not. This is the conditions is part of subset, right? So subset function. So basically, these are the kind of conditions. Say I say temperature is greater than 80, right? So day is equal to 1. Just try it out and see if that works. Hopefully, it should work. Actually, there should be no reason why it doesn't work. Hmm, that's okay. Uh, 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 just see if this works with an ampersand in between, something like that. I got your point, Anmol. Good question. But see if that works with the a subset will logical expression indicating elements or rows to keep missing values are taken as false. Now let us look at the so it's a logical expression. So as long as any logical expression that R understands is given to it, it will take it. Okay, let's see. Let's just try this out. Yeah, we say we just need to do the subset. We don't even need to bother about hist. Okay, uh, is equal to west. This how do we? Uh, let's see if and I don't know if this will work. Yeah, this seems to work. So it has taken multiple conditions. Let's see if I was to make it. mm, let's try to understand FIPS first. Mm, Pollution dollar FIPS. Mm, 01003. Summary, which is the other numeric data here. Mm, all right, let's do longitude or latitude greater than 38. Okay, so we do this. We say latitude greater than 38. Okay, so I get some values, but we don't know how many they are. So what we do is we say n row. N row. Mm, what's the function for count? I just n row is normally for the number of rows when it is. Now this is just a straight away scalar basically. So I have to count the number of elements in a scalar. How is it done? I'm sure it's not n row. N row is only for matrix or vectors. So the scalar. I've forgotten the function. Can somebody remind me? I just want length. No, no, this will not give us. Okay, so this is 254. If I was to say less than, yeah, right. So it's actually working on mole. Yeah. So I can actually have multiple conditions using the ampersand. Is this fine? Can I move ahead? For multiple, can we use with func and subset together? Which one? Which function? Which function would you want to use for multiple conditions, Lavita? So to all of you also it is clear what I did now. Anmol had a question that can we have multiple conditions here, uh, and basically the help for subset says that okay, as long as it's any logical expression it will be taken. We need to just get back to what are the different logical expressions that are available. All right. Oops. Okay, fine. So let me just move ahead. So basically we've seen how we kind of subset it. All right. So we've taken care of this. And now we can do the same thing using a scatter plot. So again, we will end up learning some features, more features of this. So I've just added something to slide 8 just to show that how I can plot multiple graphs. I'm skipping that. Slide number 19. So I'm saying, okay, uh, what I want to do is I want to do a XY scatter plot, all right, wherein I take the latitude and then the pollution levels. Okay, so latitude will come as the x-axis and the pollution levels will come as the y-axis. That is, just see line number 169. Okay, and then so I do this. So first thing is I set my MF row as 1 is to 1. Okay, then I draw the plot. So now if I draw this plot, this is what I get. Yeah. So now what I do is I draw an AB line such that the height is at 12 numbers. So what will happen is at h is equal to 12, at height is equal to 12, I get a horizontal line. All right. So I get a horizontal line. Line width is 3, so that's the thickness, and line type is 4. Let's say if I change this line type, I make it 6. All right. And then I execute this, I get a different kind of a line. All right. And then I can have a different color. I can say color is equal to red. Is this clear how I'm drawing the AB line? Okay, right. So coming to slide number 20. So now what I want to do is I want to actually plot so this data is for all the regions, right? West and east. Now how do you do it such that you can plot the region for the west in different color and region the data points for the east in different color? So now look at this command. Okay, line number 173. Now this will be a little tricky to understand. Okay, all I'm doing is I'm saying I'm adding one more value here. I say color is equal to pollution dollar region. Let's see what does that do. So when I execute this, what has happened is I see red and I see black, but I don't know which one is which, by the way. Okay, so what has it done? It takes, so pollution dollar region, what is that? If I was to just do pollution dollar region, I get actually, let us do this here, right? So I say pollution dollar region. I get west, east, and west, and so on. But know that it's a factor. Therefore, I see the levels also, east and west, right? Now, what is happening internally is what actually this command is equivalent to me saying that color is, let me correct, and I say color is equal to 1 comma 2. So which means 1 for the uh, first kind of data. Wait, no, this will not work. Mm, yeah. So how does the color is equal to region work? Tell me, how is this working out? How is the color is equal to region making it either black or red? Color is equal to region is such a huge set of data points, right? If I was to take the length, am I missing out on something? I hear these sounds. Is somebody getting dropped out and dropped back in? So east is not black color. What is happening is east is equivalent to 1. Okay, and 1 is equivalent to black color. West is equivalent to 2. 2 is equivalent to red. But even then, still tell me, how are we getting this plot? Try to understand this. When I say color is equal to region, I am actually getting the whole, as many data points here in color is equal to region as there are in the whole of the PM25. What is happening? Each point, each data point, say whatever is the data points that are there, right? Give me 1 second. Where did your questions window go? Can somebody just type something in the chat? I'm not able to see the questions window. It'll just pop up, I guess, once you type anything. Uh, just sec. I can't see your. I can't see basically your chat. Just sec. Huh? Give me 1 second. No, what has gone wrong? Oops, here. Okay. All right. So what is happening here is color is equal to region. Say let us say that pollution dollar, or let me explain it this way. Let me just take a very simple example here. I say plot. Okay. Uh, I say C 1, 2, 3, 4. All right. And then I say C 10, 12, 13, 16. All right. And then I say color is equal to C 1, 2, 6, 7, 5, 7. Okay. What am I getting here? Do you see? I'm plotting 4 points here. The first one is black. Why is it black? Because the color is 1 here. All right. The next one is red because it is 2. 5 stands for blue and therefore I get the 5. 7 stands for yellow and therefore get a yellow color. I'm not sure whether the yellow color is visible to you, but I have these 4 points here. So 1, 2, 3, 4. They are on the x-axis. 1, 2, 3, 4. And then the y-axis has these 10, 12, 13, and 16. Is this clear now? So same thing is getting used here. When I say color is equal to region, either it is east or it is west. Either it is east or west. So now because it is a factor, east gets converted into 1 and west gets converted into 2. And therefore what I see is either red dots or black dots. Is this clear now, you guys? Is the line number 173 clear? What is it doing actually? So it is not no condition there. There isn't any condition there. Sarvani, it is not a condition. It's just that it is, look at this line of code here. Okay, what I'll do is I'll keep adding these small things as I explain inside the code, uh, so that maybe what I'll do is I'll start creating blank spaces. Okay, just give me 1 second, huh? Let me just give it a logical end and let's break for the day. Yeah. um it could be anyway. It's just that factors are such that if you look at the levels, it says levels are east and west, right? East, then obviously automatically it'll be 1 and 2. In case you change the level such that east becomes 2 and west becomes 1, that will get taken care. So not an issue on Anmol. So that has more to do with factors rather than anything to do with anything else here. Okay. Okay, so let me just, so now see, for week 1 we have about 400 lines of code. Okay. uh, Now the reason for me to cover kind of the theory was that I think you should be in a position to take the quiz 1 and very easily, right? I would strongly recommend you finish off the quiz 1 today. Okay, it's just something very theoretical. Okay, and you take it up so that the next class, what I want to do is, we have 2 classes this week, right? um, the third class for sure will go for doing the project. Okay, but in the next class we will go through all of this code. Okay, so we'll go through the whole detailed code, and if you have already executed these lines of code, it'll become much more faster and easier for you to understand it in the class later on. I mean, so is that all right? Do you think you'll be able to take the time out to just kind of try to execute these lines of code and see what's happening, and note down whatever you don't understand somewhere? Or even if you can't note down, just kind of execute them one by one and see what is happening. Yeah, should not take you more than 1.5 hours. Okay, and you have plenty of time. Like, our next class will be on Thursday now, right? So Thursday morning. Is this fine? Voice is cracking. Wait. Let me just repeat. What I'm saying is, if you guys go through the week 1 coder file on your own, so that in the next class on Thursday when we cover it, uh, yes, I have recorded the session, Debashri. Who needs it? Uh, okay, Debashri. Uh, I will upload it. So what I'm saying is that if you guys go through the week 1 coder file, okay, and you execute these lines of code, okay, at least execute till you will see some portion is, the slides portion, at least that much you take care of, right? So let me just uh, so till this line number 330, if you can manage to do this, okay, uh, then what will happen is when we come back to class, things will be much more clear to you. In fact, you will actually come up with some questions, or rather the understanding will be much more deeper, right? So ideally on a Thursday itself, if we actually start off for the project, no, they'll be very good, because then Thursday our class is there, and then Friday and Saturday the class will be there, and Sunday is the submission for the project. Instead of waiting for the last minute, if you submit the project earlier, it'll be more fun also. Secondly, what happens is when you have more time, no, it's not that you're spending more time. At least you know that the deadline is not sitting on your head. You can experiment with things. You can ask yourself questions, you can ask somebody else questions, you can come back to me and say, why is it like this, why is it not like this, and you actually end up learning more. Yeah. So I would want that you please go through the code, and it's not really as boring as having to go through the videos or anything. I've taken care of all of that for you. All you need to do is just execute the lines of code. That'll be interesting. Yeah. Is this fine, all of you guys? Do you think you can manage to just run through these lines of code, execute them yourself? Though we will be repeating it in class, but still once you have done it, it will be faster. Okay, Shruti. Shruti says yes. Okay, what about the rest of you? Okay, Sarvani. What about the others? Can you take out the time? So you know what happens? This way it will work very nicely. We just need to meet thrice. The rest of the time, all you need to do is just be a little disciplined. Otherwise, what ends up happening is we start having to meet longer, more number of days. Once we have to start meeting more number of days, then you guys, for it becomes a burden for you, right? And then everything lags behind. So it's better that we stick to the 3 day system, but you guys keep putting your effort. My voice is cracking. Uh, okay, all right. I'm planning to take an even faster connection, but I don't think that'll help. I'm going to help get myself a 100 Mbps connection. So I think it'll be faster than the whole of the university that you have. Uh, so hopefully these guys will visit me in a day or so. So so then definitely you can't give me any reason why it's not. So it will definitely not be from my end once I have an 100 Mbps connection. Okay, so all of you please go through the code, please. Yeah, yeah. 100 Mbps. So no, I talked about, not really. I don't think it can. There are some issues with me coming to the university. So moreover, this month is very crucial for me. My case is almost going to get decided at one level. So at the lower court, the decision will come in my court case. Okay. So which means either again become a $1 million millionaire, or I'm no one. Okay. So. Uh, so this month the case will get an outcome, and then we'll see what we do next. Okay. So if I become a dollar millionaire, then I have no problems. I'll easily come to the university. I can take care of. Yeah, not just a millionaire, dollar millionaire. So so but if it doesn't happen, then we'll see. Because with that kind of money, then I have no problems. I can take care of whatever other issues are there that are there. Okay, I'll do that. So okay. But dollar millionaire is nothing these days, almost everyone I know is a dollar millionaire. All my relatives and all. So, anyways, okay then. So you guys work on the code, and we will meet on Thursday. Uh, so that's it for now. I'll find out. The dollar millionaire. Okay, Subbu. They normally get married to the Agrawal community only. Okay. Salman also needs to convert to Agarwal. Already converted. Lavita is Agarwal. Okay. Subul is Telugu Agarwal. Okay. Yeah, we'll look for a boy. I'm sure then she must be a dollar millionaire if she's an Agarwal. Okay then. Okay, bye Kartikeya. Jai Gurudev. Bye Shruti. Jai Gurudev.